Good morning to all. Today we'll revise on ray optics and we'll start from the content refraction. Since the reflection part is out of syllabus this year due to COVID-19, so we'll directly start the refraction part, and today we'll just study about the refraction of light through the plane refracting surface, and for the curved refracting surface we'll discuss this later on. I'll give some idea on theory as well as on your how to solve your numerics part. And to solve your numerics, you have to remember lots of formulas over the ray optics or any kind of content. Make a note or a formula copy for you. Let's start with the theoretical question. First, laws of refraction. Second one, that is lateral shift. Third, normal shift. Fourth one, that is TIR. So starting with the laws of refraction. First of all, you should know what is refraction. The refraction of light, that is the property of light or the phenomena of light where the ray of light that changes its direction while moving from one medium to another medium. Actually, for refraction we need two medium, two optically rarer or denser medium. For that, the properties like velocity and wavelength that will change. The properties like velocity, wavelength that will change while area of light that moves from one medium to another medium, whereas the frequency and the phase of the light that will remain constant throughout the movement or throughout, while the frequency and phase of the light that remains constant, frequency, phase and energy that remains constant when a ray of light moves from one medium to another medium. This one is one mark question, remember that. Now, for laws of refraction, we have two laws of refraction. First of all, first one is the incident ray, refracted ray and the normal to the incident surface. At the point of incident, all three will lie on one plane. And the second one is that is called as Snell's law, and this Snell's law, that according to Snell's law, the ratio of sine of angle of incidence, the ratio of sine of, and according to Snell's law, the ratio of sine of angle of incidence to the sine of angle of refraction, that will be a constant, and that constant is known as refractive index of a medium. This refractive index of the medium that will show how the medium is optically denser or rarer. Actually, this is written like this: mu12. Mu12 means the refractive index of the second medium with respect to the first medium. We are comparing how the medium is optically denser or rarer between two media. So remember this formula. This is called as Snell's law. So laws of refraction that is 2 marks. Write down two laws and also write this formula. If we generalize this formula, refractiveness of a medium, actually this is the ratio of velocity of light in vacuum to the velocity of light in any other medium. So we have another formula for refractive index. This is equals to mu equals to C by V. As we know, mu equals to mu12, this can be written as mu12. And this is refractive index of second medium with respect to the first medium. So I can write this like this, and this is equal to C by V, and this is equal to V1 by V2. While we consider two medium, this one is velocity of light in vacuum. If I consider the velocity of light in two other medium, I can write this V1 by V2, and actually this is equal to lambda 1 by lambda 2 since v equals to lambda by mu. Since v equals to lambda by mu and mu remains constant, that is why I have written v1 equals to lambda 1 and v2 equals to lambda 2 and mu that get cancelled. Remember this formula, you are seeing this formula like 2, 3 formulas, 4, 1, 2, 3, 4. There are 4 formulas over here, and all these formulas that will be needed for to solve your numerics part, like 1 mark, 2 marks question. So remember this part. Now, refractive index of a medium, that is a unitless and dimensionless quantity. Remember this, it is unitless, it has no unit and no dimension. This is also 1 mark question. Next, mu, that should not be less than 1. It is always greater than 1. Refractive index of a medium is always greater than 1 or equal to 1 or greater than 1. That never be less than 1. This is also a 1 mark question. Now, this much is all about your laws of refraction. This is for only 2 marks, and we'll next start lateral shift. So lateral shift, that means the sidewise shifting of the ray of light, that is called the lateral shift. While we consider a glass slab and a ray of light is incident on a glass slab, lateral shift. Consider a glass slab having thickness T. Area of light that goes from this medium, air medium, I am considering here air medium, and this is glass medium. Here the refractive index is mu2, here the refractive index is mu1, and the incident ray that strikes the air glass interface first, when it is refracted like this or bent towards the normal. Here I is the angle of incidence and R is the angle of refraction. Now at this point, this ray of light that is incident in the second surface or the glass air interface, that will, after refraction, that will go like this or away from the normal. If you observe that, then the original incident ray and the emergent ray, that both will have, or that both will be parallel to each other. And if this is angle of incidence and this angle of emergence, then over here I will be equals to E. Remember this, I is always equals to E. Now for the lateral shift, I am not deriving the formula for lateral shift, but actually lateral shift is the perpendicular distance between these two, incident and emergent ray. This shifting of light, while area of light that emerges or the crosses a glass slab, that is known as lateral shift of light. And for that, lateral shift, this is equals to T into sine I minus R by cos I. I am not deriving that formula right over here. You just see your notes from the previous video and derive this formula. I am just giving this formula as a to remember this to solve numerics. Here T is the thickness of the glass slab, I the angle of incidence, R the angle of refraction. For maximum lateral shift, B that will be equals to T. This for maximum lateral shift. And for this, actually you have a condition like when I equals to 90 degree, then R equals to 0, and substitute all this value, you will get D equals to T. And the maximum lateral shift will be equal to the thickness of glass slab. This is all about the lateral shift. Do not worry about the derivation part, just simply go through the previous video for the lateral shift of light and derive that formula. And for numerics part, remember these terms and the symbols which are representing all the term. Now, for multiple refracting surface, like this is one refracting surface, like the ray of light that goes from one medium to another medium, then again the first medium. Now, if I consider multiple refracting surface like this, for multiple refracting surface, this one is mu1, this one is mu2, this one is mu3, and this one is mu4, mu1, and this one is mu1. For 3 or 4 different kind of refracting medium and a ray of light that goes from first surface to the other surfaces, and here we are giving some condition like mu1 is less than mu2, that is less than mu3, and that is less than mu4, then what will be the result? Actually, when a ray of light that incident on the first surface of mu1, mu2 interface, since mu2 is greater than mu1, that will bend towards the normal like this. Again, for the second and third interface, mu3 is greater than mu2, so this will again also bend towards the normal like this. Again, mu4 is greater than mu3, so this will bend again towards the normal. But at the last interface or the 4 and 1 interface, mu1 is less than mu4. So this will emerge like this or away from the normal like this. If you consider these like incident ray, if the glass slide is absent or the mediums are absent, then this incident ray will be parallel to the emergent ray, and this I that will be equals to emergent angle. For different medium, remember that mu1 to ray going from 1 to 2 into mu2 1, mu2 3, mu3 4 into mu4 1, and this is simply equals to 1. Just remember this part, this is simply equals to 1. This is an important formula to solve your numerics. Remember this also for multiple refracting media. Now, we'll discuss on normal shift. So, what does it mean that a normal shift? Actually, if someone देखी थी वो दिन थी normal shift. Because मगर उड़े बिकर अच्छे, बिकर something किसी आपके liquid नहीं करें, सिर्फ इसी में liquid तो मैंने हो, पर जब तो मैं ये liquid रो मित्र उड़े coin टेके छाड़े, सिर्फ coin का देखी ठीक bottom में रही जो, पूरा observer, ये coin तो नहीं ला denser medium में, and an observer is observing this coin perpendicular to this. Perpendicular to this and making some angle like this. So both observer will see the coin differently. How? जैसे ये coin जेतु ये हला object to ray जी normally गला से undefeated की पड़ेगा, but जब bend ही की रहेगा ना से रहेगा, एवं होगा ये पॉइंट से दुईटा इंटरफेस पाएगा, ये हला denser medium, ये हला rarer medium, while ray of light that goes from denser medium to the rarer medium, the ray of light that bends away from the normal. If this bends away from the normal, then this observer will feel like that the coin will be, or the coin may be here. He finds the coin here instead of here. That means this observer will find the coin here and this observer will find the coin here. देखिबंतु जे ये हला actual depth of the coin or real depth of the coin, while this part, that is the apparent depth, that means apparent depth is false depth or appeared depth. So real depth and apparent depth, there are two terms, real depth and apparent depth. When actual depth of the coin, that is called as real depth, and the false appearing of the coin, that is known as apparent depth. And these two terms are connected with a formula, that is mu equals to real depth by apparent depth. Remember this formula? Now, coin में जो इन्हें थी ना, actually नहीं होचे, but ताकि feel वाला जैसे इजागर आवश्यक होगी, तो ये normally जो shift है वाला, ये shifting, और मुझे normally हला ताकि हम क्या करो, normal shift है ना, और ताकि हम mention करो symbol x. ताले derivation करा ही तो, देखो ताकि तुम्हें notes रहे, and x will be equals to formula में t or real depth into 1 minus 1 by mu. T, you can take this as t, real depth, that is equal to actual depth, rd into 1 minus 1 by mu. Actually, I have taken this example like that coin or the object is inside the denser medium and the observer is in the rarer medium. So here the real depth is actually greater than that of the apparent depth. But it is also seen that if the condition that is reversed, like if the coin is inside the rarer medium and the observer is in the denser medium, then the real depth will be less than that of apparent depth. Remember this formula remember this formula. Now, for multiple liquid like this, if you have a container with some immiscible liquid, like this liquid cannot mix with the second liquid, and this liquid has a refractive index of mu1 and this liquid has a refractive index of mu2, then the apparent depth formula that will be changed to like this. This is real depth 1 and this is real depth 2. So real depth 1 by mu1 plus real depth 2 by mu2. This is for multiple liquid, while the two liquids that cannot be mixed, and for that the apparent depth formula will be like this. This is also important. Question may be asked from this using this formula. So remember this formula. Now over to the last term, TIR. TIR or total internal refraction. Sorry. Now over to the fourth part, that is TIR. Now over to the fourth part, that is TIR. This is a 3 marks question. 3 marks question. This means or this stands for total internal reflection, since when a ray of light that moving that going from one medium to other medium, but that doesn't crosses the medium and it will reflect back to the same medium, and for that case that refracting medium will behave as a reflecting medium, and for that this term is known as total internal reflection. Total internal reflection actually that occurs in a refracting medium, like it actually happens for two conditions only. the rays would go from denser medium to the rarer medium, and the ray of light that is incident on the first medium, the angle of incidence would be greater than that of critical angle. And what do you mean by critical angle? Actually, critical angle, this is mu2 and this is mu1, and mu1 is less than mu2. तो गोटे रे ऑफ लाइट तो ट्रावेल करूचे तुम डेंसर मीडियम रु रेयर मीडियम के ट्रावेल करूचे से टाइम में रे ऑफ लाइट का बेंड होचे जेकी ये रेयर मीडियम या आगे फ्रॉम नॉर्मल जेकी बेंड करवा बट सो क्रिटिकल एंगल कोई की नहीं जाउ जैसे कि से होचे ना फॉर क्रिटिकल एंगल ऑफ इंसिडेंस ये आई हला से टाइम में तुम तक आईसी कहि के मेंशन करबो एंड ये क्रिटिकल एंगल का डिफरेंट मीडियम में डिफरेंट रहबो फॉर this medium, if this is critical angle of this medium, then the ray will be refracted like this. That means the angle of refraction will be 90 degree. And for that moment, the angle of incidence will be known as the critical angle of that medium. So, when area of light that is incident on the surface greater than that of the critical angle, then the ray will be refracted, the ray will be reflected instead of refracted. Like this, the same medium I have taken, this one is mu1, this one is mu2. If I have incident that greater than that of critical angle, this one is angle of incidence is greater than the critical angle. Now, this ray will be reflect like this. And this is all about total internal reflection. TIR रो बहुत गुडे एप्लीकेशन जेटा कि तमे डे टू डे लाइफ रे तमे देखि पाउछ लाइक डेजलिंग ऑफ डायमंड, फॉर्मेशन ऑफ मिराज, साइनिंग ऑफ एयर बबल्स इनसाइड वाटर. इवन सब जिंस दैट हैपेंस ड्यू टू TIR. दैट मींस से जगह रे गोटे रिफ्लेक्टिंग सरफेस रे भी रिफ्लेक्शन हे पाउछ. And this is perfectly or the totally reflecting case होचे. That means कि all incident ray that is reflected to the same medium. Our best example जेटा कि हम डे टू डे लाइफ रे भी यूज करू छु कम्युनिकेशन पर्पस रे फाइबर ऑप्टिक्स यूज होचे. फाइबर ऑप्टिक्स केस रे भी सेम जिंस नि आइ छै जेंतरे कि किसी डाटा को the speed of light the data has been transferred from one point to another point, and the fiber optics that is cheapest and highly recommended for communication purpose. Remember that the application of fiber optics, that is, or the basic principle of fiber optics is TIR. Now, TIR, if you go through the derivation part, will have formula like sin IC that is equals to 1 by mu or 1 by mu1 2. Again, since mu that depends on the wavelength of light, so critical angle also that will depend on wavelength of light. If the wavelength of light changes, then mu will also be changed. As you know that the refractive index of a medium is inversely proportional to the wavelength of light. That means the critical angle of a medium is directly proportional to wavelength of light. Wavelength of light, that means the red color of light has the maximum wavelength, and for red color of light, the critical angle of that medium will be maximum and the refractive index of that medium will be minimum, whereas for violet, that is just reverse of that. That means for violet color, the refractive index of the medium that will be greater, and critical angle that it will be minimum, as the wavelength of violet is much more that is minimum. Let's start some numerics on ray optics. The first question is, At what angle must a ray of light that is incident on a glass having a refractive index 1.5 so that it is refracted at an angle of 30 degree? Also find angle of deviation. And for this question, you should remember the Snell's law. Since the given data is like array of glass, or this can be written as mu g, that is given 1.5. Another, that the ray is refracted at an angle of 30 degree. That means I is given here 30 degree. Next, the question is asked, find the angle of incidence. We have to find I, and angle of deviation. You have to find angle of deviation delta. Since the ray is traveling from the air medium to glass medium, so we can take mu air as 1, and the first medium as the air medium. So using Snell's law, we have sin I by sin r, that is equals to mu 1 2, or sin I by sin 30 degree, that is equal to mu 2 by mu 1. Here sin I, that is equal to sin 30, and the first refractive medium that is taken as air medium and the second refractive medium is taken as the glass medium. So I can write this mu g by mu a. Substitute all this value and find out what is sin I. Sin 30, that equals to 1 by 2, mu g, that is given 1.5, and mu air, that equals to 1, or mu vacuum, that equals to 1. 1.5, that means 3 by 2 by 2, 3 by 4. 3 by 4, that is equal to 0.75, and I is equal to sin inverse 0.75. Now, to find out, this is the value of I. If the value of sin I, or the value of sin I, if that is given 0.7, here we find out that the sin I equals to 0.75. If sin inverse 0.75 is given to you, that value is given to you, then you can easily find what is the value of I. Now, to find out angle of deviation, you have to remember that angle of deviation is an angle, that is, if a ray is incident on an interface and that is refracted through this angle is R, then the original incident ray that will goes in this direction if the second medium is absent. If the second medium is absent, then the incident ray will go like this, but due to presence of the second medium, the ray is refracted with an angle R. So this total angle is I, and this angle is deviated angle. Deviated angle means the angle between the incident ray and the emergent or refracted ray. So we have to find del equals to I minus R. If the value of sin inverse 0.75 is given, then substitute this value and substitute the value of I. You will find the final value. Question number 2. That is given light, that is passing from air into a liquid medium. Into a liquid and is deviated through an angle 90 degrees. Through an angle of 19 degrees. when the angle of incidence is 52 degree. Under what condition TIR occurs, that will occur also find critical angle, given that sin 52 degree, that is equal to 0.78, and sin 33 degree, that is equal to 0.54. First of all, read this question and try to find out what kind of data is given from this question. See, the deviated angle is given like 19 degree. For what angle of incidence? That is, angle of incidence is 52 degree. Angle, you have to find critical angle. That can be written as C or IC. Critical angle. And for critical angle, the TIR will apply the TIR formula, and before that we have to find the refractive index of the liquid. Since that value is not given here, you have to find out from the we have to find out this value from the Snell's law. Since from Snell's law sin I by sin R, that is equal to mu1 2. Sin I, that is given I, that is value that is 52 degree. R, that value is not given here, but we have to find out that from this value angle of deviation 19 degree. Then R will be, since this light that goes from air medium to liquid medium, that means I, that is greater than R, and del, that will be, and R, that will be I minus del. From the previous formula, from the previous question's formula, you can find out R value, that is equal to I minus del. And here, this is mu2 by mu1. Sin 52 by sin I minus sin del, sin I minus del. I value 52, this much is 19, that means sin 33. Mu2, that is liquid medium, that we don't know, and mu1, that is air medium. Substitute all the values, you can find out mu2 or mu liquid, that will be 1.44. Now, to find out under what condition TIR will occur, you have to remember that TIR only that will occur for two conditions. First of all, the light should go from denser medium to rarer medium, and the second one is the angle of incidence that should be greater than that of critical angle. And for greater than angle from the critical angle, we have to find out what is the critical angle for this air to liquid interface. And we have the TIR formula like this. What is that? Sin IC, that is equals to 1 by mu liquid or mu. Sin IC, that I don't know, and we have to find out this, and mu liquid, that we have find out like 1.44. Substitute, calculate these and find out what is IC. IC will be sin inverse 0.69. 0.69. So the condition for TIR to occur, that is, the rays should go from liquid to air medium and the angle of incidence should be greater than this much. Now over to the third question. And the third question is, a fish is at a depth of 30 centimeter below the surface of water. Below surface of water. What will be the distance between the fish and its image? Given mu water, that is equal to 4/3. If you read this question is from normal shift. Since the fish is at a depth of 30 centimeter below the surface of water, that means here the depth of the water that is given 30 centimeter. While the question is asked, what will be the distance between the fish and its image? That means the real depth and the apparent depth distance is asked here, or we have to find out the normal sheet. Here the refractive index of water is given 4/3. So go to the formula, and the formula for normal sheet, that is equal to thickness of water or depth of water into 1 minus 1 by mu. Thickness is given 30 centimeters and this value is 4/3. Solve these and find out the result, that is equal to 7.5 centimeter. This one is normal sheet. Next numerics that we will cover in the next class. So you all have to remember the formula and just practice on the question which are given to you in the PDF format. And if any doubt, then you can ask me or your sir. Thank you.